I heartily welcome you all to Math Simplified by HM. It's great to see everyone here. Building on our last session where we applied the Pythagoras theorem to acute angle triangles. Building on our last session where we applied the Pythagoras theorem to acute angled triangles. Today we are diving into the world of obtuse-angled triangles to see how the theorem transforms. Please take a moment to like, share this video with your circle and subscribe to the channel with the bell icon turned on. Ready for the proof? Grab notebook, use the pause button whenever you need, and let us get started. Application of Pythagoras theorem to obtuse angle triangle. A step-by-step geometric proof. The theorem statement: given in triangle ABC, angle C is an obtuse angle. Construction: draw segment AD perpendicular to segment BC. We have here extended BC to the side of C. Target objective: we have to prove AB square is equal to BC square plus AC square plus 2 into BC into DC. Setting up the variables. For simplicity, let AB is equal to C, AC is equal to B, BC is equal to A, and altitude AD is equal to P, and let DC is equal to X. Since BCB lie on a straight extended line, the total base segment DB is equal to A plus X. Step 1 of the proof. In the large right angle triangle ADB, apply the Pythagoras theorem. ADB. AD is perpendicular to BC. Therefore, ADB is a right angle triangle. By Pythagoras theorem, we get AB square is equal to DB square plus AD square. Substituting our defined variables, we get C square is equal to, in bracket, A plus X bracket square plus P square. Expanding the binomial A plus X bracket square, we get C square is equal to A square plus 2AX plus X square plus P square. Name this as equation 1. Now, in triangle ADC, this is also a right angle triangle. So, by applying the Pythagoras theorem, we get AC square is equal to DC square plus AD square. Substituting our defined variables, we get B square is equal to X square plus P square. Rearranging to solve for the artificial altitude P square, we get P square is equal to B square minus X square. Steps 3. Algebraic substitution. Substitute the value of P square from equation 2 into equation 1. Original C square is equal to A square plus 2X plus X square plus P square. Substitution gives C square is equal to A square plus 2X plus X square plus B square minus X square. The plus X square and minus X square get cancelled to each other, leaving us with C square is equal to A square plus 2X plus B square. Final conclusion: from our algebraic substitution step, we have C square is equal to A square plus B square plus 2AX. Substituting the original side lengths back in place of the temporary variables, that means C is equal to AB, A is equal to BC, B is equal to AC, and X is equal to DC, we get AB square is equal to BC square plus AC square plus 2BC into DC. Hence, we have proved the theorem. That concludes our proof. Let this inspire you. Don't settle for the minimum. Be like the obtuse angle triangle theorem. Push further, add that extra value, and exceed every expectation. That means Be like an obtuse triangle theorem. Don't just settle for a square plus b square is equal to c square. Push further, add that extra 2bc into dc and achieve more than what is expected. Thank you for your wonderful attention today. Before you go, please like, share this video with your friends and colleagues and subscribe to the channel. Make sure to click the bell icon to stay in the loop. Enjoy a great time.